Today we're going to be doing geometric series. Remember, we just did geometric sequences, and a sequence is a list and a series is a sum. So now we're just going to take that list of geometric terms and add them up. So just remember what everything means here. The S sub n is the sum. A sub 1 is our first term. The R is our common ratio, and that's a number you're going to keep multiplying by to get to the next number. And finally, the only one I haven't really done anything with is n, and that is just the number of terms. So if we're going to add 5 numbers, then n would be 5 there. Alright, one thing kind of important to note is that our common ratio is not going to be 1. If it's 1, then the numbers are never going to change. So, let's try some of these. Alright, so the formula is still up there. We need to know what a sub 1 is first, and that's always the first number in the list, so you'll see that right here. That's 2, so a sub 1 is 2. So now we have this number. We need to know r, and that's what we're going to be multiplying by each time to get to the next. So take a look. To get from 2 to 1, it's half the size. If you're ever not sure what to do, you can always take the second number divided by the first number, and that gives you 1/2. So we've got r. We need to know how many terms are in this list, and we'll see this right there. So the number of terms in this list is 6. Okay, so we now have all the numbers that we need to find the sum of our first 6 terms. So I'm going to plug into the formula. My first term is 2. 1 minus the common ratio is 1/2. So I've got 1/2 raised to the 6th power. All of this divided by 1 minus 1/2. Now I just need to do some work. Alright, so we've got 2 times 1 minus 1/2 to the 6th power is 1/64. 1 minus 1/2 is just 1/2. So 1 minus 1/64, I now have 2 times, remember 1 is 64 over 64, so you could use a calculator, but you really don't need one. So 63 over 64 divided by 1/2. So this right here, the 2 and the 64 cancels out to be 1 and 32. So right now I've got 63 over 32. When you divide by 1/2, that's the same as multiplying by the reciprocal. Alright, I just fixed that. 63 over 32 divided by 1/2 is the same as 63 over 32 times the reciprocal, so I'm multiplying by 2 over 1. And the 2 and the 32 reduce. So my final answer is 63 over 16. And again, you probably could have gotten that a lot quicker. I tried to show all my steps there so you could see where things were coming from. Another thing I want to point that you could have done is in the list, we had 2 as our first number, 1 is our second number, there's our third, fourth. If you kept multiplying by 1/2, the next number would have been 1/8, and the final number would have been 1/16, and then you could have just added all those. You would have gotten the same 63 over 16. So yes, that is fine to do that. It's just that sometimes maybe I want the first 16 terms, and then you probably don't want to mess with that. Alright, let's try another one. Alright, I'm going to go ahead, I'm going to erase all this work so that I can have some room to work. Alright, if you take a look at what we have here, I have a sub 1, r to the n minus 1. So there's the formula that we used last time, our geometric sequence formula. If you notice, this is in the exact same format. So a sub 1 is this number right here. So a sub 1 is 32. My r is this number right here. So r is -1/4. and n is right there right now, so we don't know it's I. But then if you look back here at my summation notation, it says to start by plugging in 1 and then stop by plugging in 4. So if you plug in a 1 and then a 2 and then a 3 and then a 4, n is 4 terms. So we end up with 4 terms. So now I have all 4 of those. I'm just going to plug this into my sum formula. So the sum of the first 4 terms is equal to a sub 1 is 32, 1 minus negative 1/4 in parentheses to the nth power, n is 4. All of this divided by 1 minus r. Now, be careful when you're doing this work. First thing you want to do is you want to do the negative 1/4 to the 4th power. So, I'm going to run out of room again. So I've got 32, 1 minus negative 1/4 to the 4th power is positive 1 over 256. All of this divided by 1 minus 1/4 becomes a plus, so I really have 5/4 in my denominator. I'm going to work backwards so I can do this. So now I've got 32, 1 minus 256, 256 is 255 over 256. All of this divided by 5/4. My 32 and my 256 simplifies to be 1/8. So right now, I'm going backwards more, I've got 255 over 8 divided by 5/4. Remember, dividing is the same as multiplying by the reciprocal. So times 4/5. We can reduce here. That becomes a 1. That becomes a 2. Oops. I can simplify my 5, and that becomes 51. So my final answer is 51 over 2. And yes, I do want you to leave it as a fraction. Alright, let's try a couple more. Okay, so on this problem, I have my a sub 1 is 2. I know r, by looking at this, I'm multiplying by 2 each time to get to the next term, so my r is also 2. The only problem is I don't know what n is equal to, so n, I'm not sure. I do know that my last term, my a sub n, is equal to 256. So what I'm going to have to do is go back to my geometric sequence formula, which is a sub n equals a sub 1 times r to the n minus 1, and plug in everything there to figure out how many terms there are. So I know a sub n is 256. My first term is 2. I know r is 2. And then to the n minus 1. So I can't multiply 2 times 2, but I can divide by 2. So let's come down right here. So I have 128 is equal to 2 to the n minus 1. Now, since my variable is up in the exponent, I'm kind of stuck. So in order to solve this, I can log base 2 both sides. And the reason I'm picking a base 2 is because I want all of this stuff to just disappear so that my right side is just a plain old n minus 1. Remember from the log chapter, you can type log 128 divided by log 2 into your calculators. So take a minute, try that. You'll find out that that is equal to 7 is equal to n minus 1. So my n is 8. Now that I know what n is equal to, I can fill it in, and I can plug everything into my sum formula. So, one thing I do want to point out too, if you come back to the log step, I know some of you kind of freak out with the logs, that's not a big deal. If you notice that you can take 128 and break it into a base of 2, mess around with the numbers on your calculator, 2 to the 7th is the same as 128, and then you have this exact same step right here. just side note. All right, so now we're going to go ahead and do the sum formula for this problem. So I have 8 terms. The sum of my 8 terms is equal to a sub 1 is 2, 1 minus r is 2 to the 8th power, n was 8, divided by 1 minus 2. So do this work. I get 2, that's going to be a 1 minus 256, all of this divided by negative 1. So 2 times negative 255 divided by negative 1, and my final answer is going to be 510. Alright, let's try one more. Alright, again, I'm just going to clear all this stuff off so that we have room to work. So, again, I'm ignoring this problem is here, I need all this room. Alright, so go through what you need. You need a sub 1. A sub 1 is right there. So a sub 1 is negative 3. I need r. R is right here. It's the number that is raised to the n minus 1. So r is 2. And then I need my number of terms. So if you look here, I'm going to plug in a 1, and then a 2, and then a 3, and then a 4, and then a 5, and a 6. The other way we found it is we took the top minus the bottom plus 1. So top minus bottom plus 1, which is just going to give you 6. Alright, now all I need to do now is plug everything into my sum formula because I have everything I need. I know that my sum of my first 6 numbers is going to be a sub 1 is negative 3 times 1 minus r is 2 to the 6th power. All of this divided by 1 minus r, which is 2. I have 3, 1 minus 64 divided by negative 1. I have 3 times negative 63 divided by negative 1 to give me a, sorry, I dropped my negative 3 here. I just noticed that. Sorry. So negative 3 times negative 63 is positive 189. Divided by negative 1 is negative 189. So my sum is negative 189.